Hello everyone, today we are going to learn about number systems. Number systems are the technique to represent numbers in computer system architecture. Every value that you save into a computer's memory has a defined number system. So today we will understand what number systems are and how the conversion of one number system to another takes place. So these are the number systems: decimal system, binary, octal and hexadecimal system. So we will understand that how many digits that these systems contain. In decimal system, we know that the digits are lying between 0 to 9. In binary system, there are two digits, which is 0 and 1. In octal system, it has 8 digits from 0 to 7. And in hexadecimal system, it has 16 digits, which comprises of alphanumeric numbers, which is 0 to 9 and A to F. So we will now understand how conversion of one decimal system to another takes place. So stay tuned. So firstly we will understand how decimal system to binary conversion takes place. Let's say you have any number, let's say 1, 2, 3, 4, 5. Okay, let's say you have this number. So if you want to convert this number into binary, what you'll have to do, if I want to represent this in a decimal system, what I'll do is I'll put a parenthesis and then I'll write a small 10. It will show that the number is in decimal system. So suppose if I want to convert this number into a binary number, what I'm going to do is I'm going to divide this by 2. Why 2? Because binary has only 2 digits, which is 0 and 1. So whatever the remainders will be, I'll write it down here. So now if we'll divide by 2, we'll get 2 1 times 2, 2 7 times 14, and then 2 2 times 4, 1 will come up here. Now if I again divide it by 2, it will be 2 times 3 is 6, and then we get 0, 8, and then it will come out to be 6. And so now the remainder would be 0. Now if I again divide by 2, it will be 1, 5, and it will be 4, and it will be 3, and it will be again 0. And then again if I would divide by 2, it will get 2, 7 times 7, 7 times 7, 2 1 times 2, and it would get come here. So again if I divide by 2, it would be 3 times 6, and then 8 times 16, and then 5 times 10, and then it would come up 1 here. Then if I again divide by 2, I'll get 2, 1 times 2, and 2 9 times 18, and 2 to the 4, and 1 would come up as a remainder. 2 9 times 18, and then 2 6 are 12, so it would be 0. And then I'll get 2 4 times 48 times, and then again I'll get 0, then 24 times, again I'll get 0, then 12 times, then again I'll get 0, then 6, 0, 3, 0, 2, 1 times 2, so again it would come up 1 here, right? So this last one would come up here at the very bottom. Okay, now in order to convert this decimal system to binary, we need to have a bottom to top approach. Means if I want to convert this number into binary, how I'm going to write it as, I'm going to write 1 1 0 0 0 and then 0 and then 1 1 and then 0 1. So this is how I will write this number in binary form. So now we will understand how conversion of decimal system to octal number system takes place. Let's say you have any other number, let's say 1 2 3 4 5. Okay, now if I want to convert this decimal number into octal number, what I'm going to do is I'm going to divide here by 8. Why 8? Because octal number system is represented by 8 digits. So if I'll divide by 8, I'll get 8 1 times 8. 4 would come up here, 8 5 times is 40, 3 would come up here, 8 4 times is 32, and then 2 would come up here, 8 3 times is 24, and then 1 would come up as a remainder. Now if I divide by 8, I'll get 8 1 times is 8, and then 7 would come up here, 8 9 times is 72, 23 would come, then 8 2 times is 16, so you will get as 7. So again if I divide this by 8, I'll get 8 2 times is 16, and then 8 4 times is 32. So it will become 0, and then 8 3 times is 24, it will again become 0. So this 3 that we are talking about, it would come up down here. So again we'll apply the bottom to top approach. So if I want to convert this number into octal number system, what I'll write is I'll write this as 3 0 0 7 1, and then I'll write a small 8 here, which will show that this number is in octal number system. Now we will see that how conversion from decimal system to hexadecimal system takes place. Let's say we will take our example of 1 2 3 4 5. Okay, and now we will divide this number by 16. By 16 we will get 771, and 9 would come up here as a remainder. Then again if we will divide, we'll get 48 here, we'll get 3 remainder here, and then if 3 times 16 3 times is 48, you will get 0 here, and then 3 would come up here. So if I want to convert this number into a hexadecimal system, we'll again follow the bottom to top approach. So this number will be represented in hexadecimal system as 3039, and here I'll write a small 16 here, which will show that the number is in hexadecimal system. So we will take another example for the better understanding of this conversion. So what I'm going to do is, I'm going to take this number 745. If I divide this number by 16, okay, so what I'm going to get is, I'm going to get 45 here. So what would be the remainder? Remainder would be 5. Now, if I want to divide this again by 16, I'll get 16 times 2 is 32. So you will get the remainder as 13, okay, and 2 would come up here, right? So if I want to apply this bottom to down approach, in order to convert this number into hexadecimal system, how I am going to write this as 2. But should I write 1 3 here? No. This is the main thing to understand, that instead of writing 3, what I am going to write. So it is important to understand that A would be represented by 10, B would be represented by 11, C would be represented by 12, and D would be represented by 13. So I'll write this number as 2D5, and there I'll write a small 16, which will represent that the number is in a hexadecimal system. Now we will understand how conversion from binary number system to decimal number system takes place. So let's say you have this number as a binary number, okay? So in order to convert this number, what I would suggest to you is, you will see this upper row, right? You will write small digits here from 0, 1, 2, 3, 4, 5, 6, and then 7, okay? Now in order to convert this number into decimal system, what I am going to do is, so wherever this is 0, you are not going to consider that. So wherever there is one digit, you are going to consider that only. So how I am going to write this as 2 raised to the power 0 into 1 plus 2 raised to the power 3 into 1 plus 2 raised to the power 4 into 1 plus 2 raised to the power 6 into 1 plus 2 raised to the power 7. So when you will calculate this number, you will get 217. So this number is in decimal number system. So this is as simple as that. Now we will try to understand that how conversion of binary number system to octal number system takes place. Let's say you have this number in binary form, and if you want to convert this number into octal number system, so what I am going to tell you here will blow your mind first, okay? So what you are going to do is, you are going to make a pair of three digits, okay? So you will get from right side, so you will get here 1, you will get here 2, but here when you will see here, these two are alone only, so they are not able to make a pair of 3 digits. So what you are going to do is, you will put 0 here, you will put 0 here, and then you will make a pair of 3 digits again. So here I am going to give you a table. So this table will help you to convert binary to octal and octal to binary. So let's say in octal we have 0, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, and then we have 7. Okay, so this is how octal number system is. So in binary terms, what I'm going to do is, so 0 0 0 would be 0, 0 0 1 would be 1, 0 1 0 would be 2, 0 1 1 would be 3, 1 0 0 would be 4, 1 0 1 would be 5, 1 1 0 would be 6, and then 1 1 1 would be 7. So this table will help you to convert binary to octal and octal to binary. After completing the table, what we are going to do is, we will understand these numbers through this table. So we will try to see what is 0 1 1. So 0 1 1 is 3, we will write 3 here. So we will see what is 1 0 0, it is 4, we will write 4 here. We will see what is 1 0 1, 1 0 1 is 5, so we will write 5 here. So after getting the number, you will write it in parentheses, and then you will write it a small 8 here, which will show that the number is in octal number system. So now we will see that how conversion of binary to hexadecimal takes place. So in binary to octal, we have given you a pair of 3 digits, but in binary to hexadecimal, what you are going to do is, you are going to make pair of 4 digits. You are going to make pair of 4 digits. So in order to convert this number, I am going to give you a table. This table will help you to convert binary to hexadecimal and hexadecimal to binary. Okay, I am going to tell you that how to make this table. So what you will do is, you write 0, you write 1, you write 2, you write 3, you write 4, 5, 6, 7, 8, 9. Okay, you write this. Okay, and then you will write here A, B, C, D, E, F. Okay, so in order to write 0, what you are going to do is, you write 0, 0, 0, 0. In order to write 1, what you are going to do is 0, 0, 0, 1. In order to write 2, what you are going to do is 0, 0, 1, 0. In order to write 3, what you are going to do is 0, 0, 1, 1. Now 4 would be 0 1 0 0. Now again I will write 0 1 0 1. Now 0 1 1 0. Now I write 0 1 1 1. Okay. Again I'll write as 1 0 0 0. Okay. And now I'll write 1 0 0 1. Now A I'll write as 1 0 1 0. B would be 1 0 1 1. C would be 1 1 0 0. And D would be 1 1 0 1. And E would be 1 1 1 1. It would turn out to be 1 0. And then it would come out to be 1 1 1 1. So this is how you make table for the conversion from binary to hexadecimal. So now this is very simple. You will what is 1110? How you will see 1110? 1110 is E and 0101 is 5. So what this number would be in the hexadecimal system? It would be E5 hexadecimal, or it may also be denoted as E5 hex. So this is how the conversion of binary to hexadecimal takes place, and also from hexadecimal to binary. So now we will understand how conversion from octal to decimal takes place. Let's say you have a number 345 octal, okay, and now you want to convert this into a decimal form. So what I am going to suggest you is, you will write a small 0 here, 1 2. The most important thing to understand here is, you will write your series from right, 0 1 2. Okay, now I'll write this as 5 into 8 raised to the power 0 plus 4 into 8 raised to the power 1 plus 3 into 8 raised to the power 2. So this is nothing but 1, so it is 5. So this is 32, and then 64 into 3, which would come out to be 192. Okay, so 192 plus 5 plus 32. So here you will get the answer as 229. Okay, so now we will try to understand that how conversion from hexadecimal to decimal takes place. Let's say you have a number 2C9B. Okay, 2C9B in hexadecimal system. Okay, so what you're going to do is, you are going to start your series from right only, 0 1 2 3. So what would be the conversion to decimal? It would be, so B would be nothing but 11 into 16 raised to the power 0 plus 9 into 16 raised to the power 1 plus C would be nothing but 12 into 16 raised to the power 2, and there you will get 2 multiplied by 16 raised to the power 3. Okay, so after solving you will get the answer as 11419 in decimal system. So in that way we have seen that how number system is important and how their conversion takes place from one system to another. So I hope you like the video, and if you like the video, please hit like and subscribe this channel, and also share it with your younger siblings so that they'll fall in love with mathematics. Thank you so much.